Okay, so why did we just show you a few problems that were kind of where weird things happen? Because in the polynomial long division, every now and then some things don't line up nicely, or you bring down a zero and you have to know what to do. So I'm going to show you what to do. Here's an example one. Everybody write this one down, please. X plus 3 going into x to the 5th plus 3x to the 4th plus 4x plus 12. Probably one of the longer ones ever. Okay. Can you see what's, just try to look into the future. What do you think is going to be weird about this one that we didn't ever have before? We've had things like x plus 3 before. What's weird about this one? Yes. The plus 12 at the end. We've had constants at the end before. I'm thinking you're guessing that if it won't work because it won't come out to 12 at the very end. But that's not where we're going with this. Sam, you see something unusual? Okay. Yes, after the first set of multiplying, we are going to have a problem. You're right. But look at the original problem. Before you actually start the problem, you can see there's something different about this. Yes? It's not that. Thank you for guessing. Yes? You're right that that's a bigger power than we usually have, but we have had some like 3s before, so it's not the size of the power. I think a few hands went up with more confidence. Yes? Yes, it is missing 2 terms right in there. Right in there. Oh, wait, not right in there. It's got an x to the 5th. It's got an x to the 4th. What it doesn't have is an x to the 3rd. There's 0 x to the 3rds. And it also doesn't have an x to the 2nd. So there's 0 x to the 2nd. And there is an x to the 1st, and there is an x to the 0. So these are the 2 missing terms. All right, so, well, let's just do this, and I'll show you. You can do it without having to have those placeholders. If you want to, it does work out a little smoother if you actually insert the 2 placeholders in here, a 0x to the 3rd and a 0x to the 2nd. But we don't need them, so let's try it without inserting them. All right, start like normal. X to the 4th will make this work because x to the 4th times x makes x to the 5th. See what I'm saying? All right, go ahead and finish it from there. Your x to the 4th times the 3 now. You lost? You're already done? Okay. What'd you have here? And then change signs, and then what happens? Yeah, that's a little weird. Now what? You got to bring this down. You bring both of them down. You're right. Technically, what you could do there is say the x to the x plus 3 goes into 4x 0 times. But if I put a plus 0 here, is that really going to change anything? X to the 4th plus 0, it doesn't really do anything, so I don't really need that plus 0 to hold the place up there. Okay, now I can bring up a 4, put a plus in there, 4x is 12. Notice I have nothing left. It appears to have worked. So that means this times this will equal that. Do you have to have that 0 plus 4 in there? No, it could just be 4. Okay? So some weird things will happen, like you had to bring down 2 terms on this one. This next one, oops, is even weirder. Try this one. I'll pause while you work on that one. Okay, so I use 2x, and then it gives me 2x to the 3rd minus 10x. Oh, wait, sorry, squared. There we go. Minus 10x squared. And then I change signs. And then I have, no, I'm screwing something up. What am I screwing up? Oh, I shouldn't have a 2x squared. I should just have an x squared up there. There we go. Sorry about that. And then that wouldn't be 10 anymore. It would be minus 5x squared, but then I got to change the sign to positive. So it's negative 4x squared. There we go. Plus 15. And now if I put in a minus 2x, I'll have negative 4x squared, so the first terms cancel. But here's where it gets a little weird. I get plus 10x. Change the signs. And these cancel nicely, but look at this. What do I do? 15 plus negative 10x. Well, you just keep going. Negative 10x plus 15. See how I wrote that? It's the same thing as what I have. I just wrote it like across instead of up and down. And now I just keep going and I say, what do I put here? Well, let's see. I need a negative 5 this time. Negative 5 times 2x makes negative 10x. And negative 5 times negative 5 makes positive 25. Change the signs. And those cancel. And now I have negative 10 left. Is there anything else to bring down? So what do you think? It's not a factor. If this had come out to 0, then we'd know it had worked. But it didn't come out to 0, so it's not a factor. It did not work. So the answer is no, it's not a factor. All right. That's just another. I don't think we need to do another one. Here's a synthetic. This is a completely different way to do the problems. And synthetic is cool because it's way faster. It's set up a lot like a long division, but it's different. Notice how it says x equals negative 3. We never use that in long division. We would have used x plus 3. You know what I'm talking about? This one's called the what? The root. And this one is the what? The factor. Okay. And then I'd go like this, x squared plus 2x minus 3. But you already know how to do that. I'm going to set this up in blue. Here's how you do synthetic division. Now, synthetic means sort of like it's related to, but it's maybe better than, or it's at least different. Synthetic oil, for instance, goes in your car, and it's way better than normal oil. Costs more too, and it helps your car to run longer and all that if you use the synthetic oil. Well, this synthetic division is way faster. You start by just putting in the root here on the left, just kind of like this was a factor that was on the left. And then you take all the constants like this. There's a 1 right there. There's a 2 there. And there's a negative 3 there. And I write them here. 1, 2, and negative 3. Now, this 1 just drops down. Now, this is just a weird little trick process that will work, and it's a lot faster, but you just kind of got to get used to how to do this. You add down, and then you multiply diagonally. 1 times the negative 3, that times that, gives me negative 3, and I put it here. And then I add down, makes negative 1. Then I multiply diagonally. 1 times the negative 3, or sorry, negative 1 times the negative 3 makes what? Positive 3. Add down, what do I have left? 0. Is there anything else left to do? Numbers to bring down? No. And if I end with a 0, that is my remainder. And that means that it worked. It is a factor. I did that one kind of slow because I was showing you how to do it, but you can see it's got a lot less steps in it than the long division does. Now, today you're going to learn how to do synthetic, and then tomorrow's homework, not tonight's homework, but tomorrow's homework, you're going to get to pick. Do whichever way, because either way works. They do the same thing. They both tell you what the roots are, or whether or not something's a root. And this, I just think you'll like synthetic better. I bet most of you will choose this way. It's all said and done. All right. I'm going to show you how to interpret the results in a minute, but we'll do that on the next video.